In this video, we learn how to find the inverse of a matrix using an equation it satisfies. Here's a matrix A, 2, 3, 1, 2, and we're given that A satisfies this equation A square minus 4A plus I equals to 0 matrix. We need to find A inverse using the value of A and the equation it satisfies. Pause the video, try this on your own. Okay, let's do this together. By plugging in the values of I, which is 1, 0, 0, 1 here, a 2 by 2, A and A square. If you plug in these values, we'll see that left hand side is in fact a 0 matrix. So we have to find A inverse. How do we do that? Well, we can use A times A inverse because it's the inverse of A. If you multiply A with A inverse, we should get the identity matrix. So the strategy is to use A times A inverse equals to I and isolate A inverse. So this is the equation. A square minus 4A plus I equals to 0. We can rearrange this as A times A minus 4A equals to minus I. Now we're ready to multiply both sides by A inverse. And before we do that, we have to specify what we're doing. There are two ways to multiply in the matrix world. If we have A equals to B, we can either post multiply. If you're post multiplying both sides by C, this means we're multiplying A by C and B by C. C comes after A and B. But if you're pre-multiplying, this means C comes before A and C. This means this is C times A equals C times B. And both of these are different. We know that A times B is not the same as B times A. They're two different matrices. So when we're solving problems like these, we have to specify what we're doing. Are we post-multiplying or are we pre-multiplying? In this case, let's post-multiply. If you're post-multiplying by A inverse, this is what we'll get. We'll have A times A, this is what we already have, times A inverse. So now we have three matrices here, minus 4 A times A inverse equals to minus I times A inverse. So we have a multiplication here, and a multiplication here. Let's look at each of them. This one is A times A inverse. We can club these two. Minus 4 A times A inverse, clubbing these two. Minus I times anything is the same thing. That's minus A inverse. So we do have an A inverse here, but we also have A times A inverse. And we can use A times A inverse equals to I to get rid of these two. We'll have A times I minus 4 times I equals to minus A inverse. Taking the negative sign here, we have A inverse equals to 4I minus A. This is what we have. A inverse is equal to 4 times I, that's something that we know, minus A, that's also something that we know. So now we have to plug in the values to get A inverse. Let's do that. A inverse equals to 4 times I, that's 1, 0, 0, 1, minus A, that's 2, 3, 1, 2. So plugging these values, we get A inverse equals to 4, 0, 0, 4, multiplying 4 to each of these elements, minus 2, 3, 1, 2. This is 4 minus 2, that's 2, 0 minus 3, minus 3, 0 minus 1, minus 1, and 4 minus 2. So that's how we can figure out A inverse using this equation. Let's try one more. A is 3, 1, minus 1, 2, and it satisfies this equation A square minus 5A plus 7I equals to 0 matrix. We need to find A inverse. Pause the video, try this on your own. Okay, now the strategy remains the same. A times A inverse, that's equal to I. So we'll use this to isolate A inverse. We have A square minus 5A plus 7I equals to 0 matrix. So this is the equation, A square minus 5A plus 7I equals to 0. Take 7I to this side. A times A minus 5A equals to minus 7I. Again, post multiplying by A inverse. This is what we have. A inverse minus 5A inverse equals to minus 7I A inverse. This is A times A inverse. This is going to be our I minus 5 times A inverse. Again, another I minus 7 A inverse. So we have A inverse here and these two will be I, the identity matrix. This is AI minus 5I equals to minus 7A inverse. So 7 times A inverse equals to 5I minus A. We can plug in the values of A and I to figure out A inverse. This is 5 times 1, 0, 0, 1 minus 3, 1, minus 1, 2. This becomes 5, 0, 0, 5 minus 3, 1, minus 1, 2. This is 5 minus 3, 2, 0 minus 1, minus 1, 0 minus minus 1, that's 1. and 5 minus 2, that's going to be 3. This is our 7A inverse. So our A inverse will be 1/7 of this. So this is our answer. This is our A inverse. Let's solve a cubic equation. We have A equals to 1, 1, 1, 1, 2 minus 3, 2 minus 1, 3. And we're given that A satisfies this equation. A cube minus 6A square plus 5A plus 11I equals to 0 matrix. And we need to figure out A inverse. Pause the video, try this on your own. All right, same strategy, let's apply it. A square times A, because A inverse will only react with one of these A's. So keeping the other two as A square times A minus 6A times A plus 5A equals to minus 11I. Now post multiplying by A inverse, we get A square times A inverse minus 6A inverse plus 5A Inverse equals to minus 11I A inverse. Now let's see what we have. This becomes I, this becomes I, this becomes I, and this becomes A inverse. So this is going to be A square times I, which is just going to be A square, minus 6A times I, which is minus 6A, plus 5 times I equals to minus 11A inverse. Now on this side we have A inverse. On the left hand side we have I, A, and A square. Now to get to A inverse, we need A square. So now our job is to find A square. We can do that by multiplying A with itself. So A square, that's A times A. Let's multiply these two matrices. We have 1 plus 1 plus 2, 1 plus 2 plus minus 1, and we have 1 minus 3 plus 3. Then we have 1 plus 2 minus 6, then 1 plus 4 minus plus, so that's going to be plus 3, 1 minus 6 minus 9, and for the last row we have 2 minus 1 plus 6, then 2 minus 2 minus 3, and finally we have 2 plus 3 plus 9. So if we simplify, we have 1 plus 1 plus 2, that's 4. This is 3 minus 1, 2. This is 4 minus 3, 1. This is 3 minus 6 minus 3. This is 8. This is 9 and 6, 15, minus 1, 14. So that's minus 14. This is 8 minus 1, 7. This is minus 3. This is 5 and 9, 14. All right. So this is how we get A square. Now we have all the ingredients. We have A square, we have A and I. Let's combine each of them. 11A inverse, that's minus A square. Take the negative sign here. Plus 6A minus 5I. So that's going to be negative of this matrix plus 6 times this matrix, the one we are given in the question, minus 5 times identity matrix. And because these are 3 by 3s, I will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So now we need to add and subtract. 11A inverse is going to be minus 4 plus 6 minus 5 minus 2 plus 6 minus 0 minus 1 plus 6 minus 0 3 plus 6 minus 0 minus 8 plus 12 minus 5. This 1 multiplies with this 5. And the last element of the second row, that's going to be 14 minus 18 minus 0. Finally, the third row will be minus 7 plus 12 minus 0 minus minus plus. So that's 3 minus 6 minus 0. And last element will be minus 14 plus 18 minus 5. So this becomes minus 4 minus 5 is minus 9. Minus 9 plus 6 is minus 3. This is 6 minus 2, 4. 6 minus 1, 5. 6 plus 3, 9. 12 minus 13, that's minus 1. 14 minus 18 is minus 4. 12 minus 7 is 5. 3 minus 6 is minus 3. And 18 minus 14 is 4. 4 minus 5 is minus 1. So this is our 11A inverse. Now we need to find A inverse. So we'll divide both sides by 11. A inverse is going to be 1 by 11 of this matrix. So A inverse is 1 by 11 of minus 3, 4, 5, 9 minus 1 minus 4, 5 minus 3 minus 1.